So we now proceed to the discussion of Laplace transform. But basically, ang gagawin lang natin dito is a review. Okay, so we take note that the Laplace transform satisfies the requirements for the convenient mathematical representation of systems using the transfer function as we discussed previously. Okay, so furthermore, the Laplace transform makes the relationship between systems algebraic. Okay, so this is the definition of your Laplace transform. Okay, wherein it is basically an integral transform. Okay, that is, kunin natin yung integral ng f of t times e raised to negative st times dt. Yung e raised to negative st na to, yung tinatawag na kernel of transformation. Okay, and every Laplace transform, or every transform na meron tayo, every mathematical transform na meron tayo, basically, um, meron ganyan, merong kernel of transformation. Okay, so now, some notations. Okay, so basically, sa time domain, okay, so yung, alam natin na yung function natin is in time domain kapag yung independent variable niya ay t. Okay, tapos yung function name is in lowercase letter. Is represented by lowercase letter. Then, itong script L na to, okay, is used to denote the operation of Laplace transform. Okay, so what happens is that kapag kinuha natin yung Laplace transform ng f of t, yung independent variable natin magiging s na. Okay? Tapos yung ating function name, okay, is now represented in the s domain as a function in uppercase letter. So gagamitin yung same uppercase letter to. Okay? Now, here we take note that s is a complex variable and is equal to s plus sigma plus j omega. Okay, so we remember this pa kasi later on, gagamitin natin yan as part ng discussion natin sa mga later topics. Okay, so the function f of t, okay, is in time domain, okay, basically, and has the Laplace transform f of s in s domain. Now, s domain is also called the complex frequency domain. Okay, so yun yung mga notations natin. Okay, now, the inverse Laplace transform is then defined as this integral. Okay. Take note na ito, okay, denotes the operation for your inverse Laplace transform. And ang mangyayari niyan is that since yung ating function is nakatransform, okay, or meron tayong function in the S domain, okay, yung kanyang function name is of uppercase letter, tapos yung independent variable niya is s. Pag natin yung inverse Laplace transform nito, magiging t, yung independent variable natin. So, babalik tayo sa time domain. Tapos yung ating function name, gagawin natin lowercase letter. Okay. Now, take note lang na kapag nag-Laplace transform or nag-inverse Laplace transform kayo, yung f of t natin is being multiplied by u of t. Okay, indicating na pag ang function nyo nakamultiply ng u of t, it means na it has 0, that your f of t is basically, your f of t is 0, yung f of t ninyo is basically equal to 0 for t less than 0. Kasi wala, 0 yung value niya for negative values of t. Okay. So, in that case, we will have yung function na to, okay, called the unit step function. Okay, so ang tawag natin dyan is the unit step function. Okay, has the value of 0 for t less than 0 and 1 for t greater than 0. Okay, so basically, ang idea dito is that pag meron kayong function, okay, pag meron kayong function na 0 for negative values of t, okay, basically you can achieve that by multiplying that function with a unit step function. Okay, pero in our case, sa mga i-analyze naman natin mga systems at saka mga signals later on na may kinalaman sa sa mga systems na i-analyze natin or i-design natin, Basically, ang unang assumption kasi natin is that we have zero initial conditions. Okay? So, as I pointed out before, mas madalas, we really do not have to write the function na nakamultiply pa sa u of t. Kasi we have this common understanding na zero naman yung value ng function natin for t less than 0 kasi nga, we have zero initial conditions. Okay? So, yeah. Now, table 2.1, okay, summarizes um, yung Laplace transform pairs. Okay? So, again, yung u of t natin, sinabi ko na to before, na yung u of t natin, pwede nyo i-substitute yun sa 1. Especially kung kino-consider naman natin yung signal o yung system, okay, na walang initial conditions. Okay? Or in the case of signals, yung walang values for negative time. Okay? So, basically, we can simply write number 2 as 1. So, yung Laplace transform is 1 over s. Ito naman, we can simply write this as simply t. Okay? So, yung transform ng t is 1 over s squared. Ito naman, simply t raised to n. Okay? Ito, this is e raised to negative at. Okay, so yan yung mga pwede nyo i-simplify dyan. Ito, kumbaga, pwede itong, pwede nyo i-treat to as 1. Okay. So, yun yung pwede natin gawin dyan para ma-simplify siya. Okay. Now, these are the properties. Okay, table 2.2 summarizes the properties. Okay, so you have the definition, linearity, okay, frequency shift, okay, time shift, scaling, differentiation, integration, final value, tsaka initial value theorem. Okay, so I believe most of this nadaan na naman natin yung nag-aral tayo ng advanced math before. Okay, and I would like I would assume na alam natin kung paano yung paggamit nito. Pero just to clarify din na itong differentiation at integration properties ang mas madalas natin gagamitin, especially here sa control systems engineering. Okay. So, to summarize itong differentiation at integration properties. Basically, pag mag-differentiate kayo sa time domain, basically, that involves multiplying s to the Laplace transform. Okay? And kapag mag-integrate kayo sa time domain, okay, that basically involves dividing the Laplace transform with s. Okay? So, papansin nyo dito, na nag-derivative kayo dito, papansin nyo na yung first term nito is basically s times of s. Okay? Yung integral nito, basically, yung s niyo or yung f of s niyo is being divided by s. Okay? So, yun yung mga dapat tandaan natin. Now, ang isa pang makikita nyo sa differentiation property is that yung order ng differentiation is also equal dun sa degree ng inumultiply mo power ng s. Okay, so kung second derivative ito, multiply mo dyan ay s squared. Kung ito ay nth derivative, multiply mo dyan ay s raised to n. Okay, although I am expecting na alam nyo itong part na to. Okay, on how to expand this part. Okay, later on kasi, kapag kinonsider natin siya sa transfer function, lahat yan mag-zero. Kasi take note, we will be considering zero initial conditions for your system. So, ibig sabihin, yung value ng f of 0 ninyo is basically 0. Okay? So, mawawala din yun. So, ang mag-matter dyan, ito talaga. Okay? So, ito namang final value theorem, gagamitin natin later on kapag interesado tayong hanapin yung final value ng function ninyo. Okay? So, ang sinasabi lang yan is that kung gusto nyo kunin yung final value, basically the final value of your function is the value of your function as t approaches infinity. Okay? Now, you can obtain that by taking the Laplace transform of the function, okay, multiplying it with s, and finding the limit of that product as s approaches 0. Okay? So, ayan. So, let us work on example 2.1 first. By finding the Laplace transform of the function f of t equals e raised to negative at cosine omega t plus theta. Okay? So, So basically, try mo natin isulat yung given. So you will have f of t equals e raised to negative at cosine ng omega t plus theta. Okay. So in this case, i-take note natin na unang-una, yung hinahanapan nyo ng Laplace transform is an exponential multiplied to a function. Okay, so ito yung exponential nyo, ito yung function nyo. So basically, applyan nyo to ng frequency shifting. Okay, so ano ba yung frequency shifting ulit? Okay, basically, kung meron kayong exponential na nakamultiply sa function nyo, kukunin nyo yung Laplace transform ng function niyo, ng f of t. Pero, yung pagkakuha nyo ng f of s, okay, o pagkakuha nyo yung Laplace transform nun, lahat ng s dun sa Laplace transform, papalitan nyo ng s plus a. Okay? So, basically, yun yung isang i-apply natin. Yung Laplace transform ng e raised to negative at f of t, okay, is basically f of s plus a. That is your frequency shift theorem. Okay, so apply natin siya yan. Kaya lang, kung ito yung f of t ninyo, ang problema, wala yan sa table 2.1. Wala yan dito. Okay, so meron lang kayo cosine omega t, pero wala kayo cosine omega t plus theta. So kailangan ito ngayon, mailagay natin ito dun sa form na meron dun sa Laplace transform table nyo. And how do we do that? So since sum of angles ito ng isang trigonometric function, okay, basically, pwede natin itong kunan ng or meron lang trigonometric property para dito. Okay, so rewriting, we will have e raised to negative at times cosine of omega t cosine of theta minus sine of omega t sine of theta. Okay, so ayan, yun yung property nito. Okay, so expand natin siya by multiplying ito sa dalawang terms nito. So you would have e raised to negative at cosine omega t cosine theta minus ayan, so cosine omega t cosine theta minus e raised to negative at sine omega t sine theta. Okay, so ngayon, nandun na ba tayo dun sa form na kailangan natin? Okay, so basically, itong cosine theta na to, constant ito. Dahil yung theta niya, constant. Take note na ang independent variable na sa given ay t. So therefore, yung variables or yung literals, okay, other than a at saka, literals other than t, like a at saka theta, those are parameters. Tsaka yung omega, sama yung omega. Those are parameters. Okay, and basically, dinefine natin yung parameters as constant sa isang particular instance o sa isang particular situation ng function ninyo. So basically, constant pa rin naman siya dito. Okay, so kung constant ng theta, constant theta is also constant. Okay, and by linearity, anong gagawin natin? Pwede natin siyang ilabas. Okay, pwede ko siyang ilabas dito. Okay, so lalabas natin siya. So basically, balik kukuha na ako ng f of s ngayon. No? So you'll have f of s equals, lalabas ko yung constant na cosine theta times. Ngayon, ito. Since ito, again, applyan natin siya ng frequency shifting. Okay, i-apply natin yung frequency shifting galing dito. Okay, kukunin ko yung Laplace transform nito. Kasi ito yung exponential So ito yung f of t. So kukunin ko yung Laplace transform ng f of t at ng cosine theta. Okay. So according to the table, okay, according to the table, yung Laplace transform nun ay ito. Okay, Laplace transform daw ng cosine omega t is basically s over s square plus omega square. So this is s square, s pala, divided by s square plus omega square. Okay. Pero, applying, okay, applying yung ito, no? Hindi pala may pakita yun. Ayan, ito. Yung Laplace transform. Okay. So, applying na the shifting, okay, yung s, gagawin natin yung s plus a. Yung plus a na to, okay, dahil yan dito, sa negative a na to. So, kung negative a ito, plus a yung ipapalit natin. Kung positive ito, minus a ito. Okay. So, ayan. Then, minus, ito naman siya. Ganun din. Itong sine of theta is basically constant. Okay. Tapos, so, lalabas natin siya. Sine of theta. Tapos ito yung exponential, ito yung f of t. So, dito pa rin tayo, ito pa rin siya. Okay. So, basically, kunin natin yung Laplace transform ng sine omega t. Okay, which is basically, ito daw. Ang Laplace daw nun ay ito. So, omega plus s square plus omega square. So, basically, that is, okay, so that is times omega over s square plus omega square. Pero, yung s, papitan natin ng s plus a. Again, applying the frequency shifting theorem. Okay? Now, simplifying that, okay, simplify natin yan. We will have, simplify natin yung unang term. So, we would have f of s equals, so ito, yung s na to, papitan natin s plus a. So, this is s plus a times cosine of theta divided by, again, yung s na to, papitan ng s plus a. So, s plus a square plus omega square. Yan yung first term nyo. Okay? Yung second term nyo naman, ito, minus, so omega to, tapos times sine theta divided by yung s ito, papalitan natin yung s plus a square plus omega square. Okay. Now, take note na ito, itong dalawang terms ito can be written in a single rational term dahil pareho naman siya ng denominator. Okay, so basically, you would now have your f of s to be, denominator mo is s plus a square plus omega square. Yung numerator mo is basically s plus a cosine theta minus omega sine theta. So that would be your, that would be the Laplace transform na hinahanap natin. Okay? So, ayan siya. So, okay? So, next example. Find the inverse Laplace transform of f of s equals 10 over s times s plus 2 times s plus 3 squared. Okay. So, pag mag-i-inverse Laplace tayo, ang mga, actually, ang titingin dito mabuti is yung denominator niya. Okay. So, dito, makikita nyo na ang denominator ko is puro linear. Okay. So, kapag ganito, makukuha ito ng simpleng partial fraction expansion. Okay? So, basically, ang mako-obserbahan nyo dito is, kapag ang denominator nyo is s lang, okay, o kaya linear siya, halimbawa yung s plus 2, o kaya quadratic siya. Okay? So, let us have this case na, na linear lang muna siya. Okay, so let us write the given. So, yung given natin is basically f of s equals 10 over s times s plus 2 times s plus 3 squared. Okay? So, since ito naman ay naka-linear factors na, so bali meron kang apat na factors, isa, dalawa, tatlo, apat. Okay? Kunin natin to sa sa partial fraction expansion. Okay, so we would now have f of s as yung ating 10 over s times s plus 2 times s plus 3 squared equals a over s plus b over s plus 2 plus c over s plus 3 plus d, okay, over s plus 3 squared. Okay. So, kung matatandaan nyo, kung matatandaan ninyo, kaya tayo na ganito kasi repeated yung isa nating factor. Okay, repeated yung isa nating linear factor. Okay, so, ayun siya. Kaya naging dalawa yung natin, dalawa yung factors natin para doon. Okay. Now, kung matatandaan nyo sa signals nyo, may tinuro tayong may natutunan tayong cover up method. Okay, pwede nyo rin gamitin yung dito. Okay, basically pareho lang naman yun. Okay, so paano yung cover up method? So, kung kukunin natin tong A, okay, bali, basically, tatakpan natin si S dito. Tapos, isa-substitute natin yung root nito, root ng denominator nito, which is S equals 0. Okay, so basically, yung A natin can be determined as 10 over s plus 2 times s plus 3 squared when s equals 0. Okay? So, in that case, this is simply lang to. 10 over 9. Kasi yung s mo 0, so this is 9. This is 9 times 2. So, 18. 10 over 18. So, this is basically 5 over 9. Okay? So, that is for your letter A. For letter B naman, okay? So, again, ang technique is, yung factor na to, tatakpan natin dito, tapos isa-solve natin siya for s equals negative 2. Kasi yun yung root nito. Okay. Later on, may itatawag tayo dito. Okay. Pero siguro tawagin natin siya pole. So, yung pole nito is s equals negative 2. Okay. Yung pole is whatever makes the denominator of this equal to 0. Okay. So, basically, yun nga yung yun nga yung root nga nito. Okay. So, pole yung itatawag natin. Later on, tatawag natin siya pole. Okay. So, yung pole nito is basically s equals negative 2. So, isosolve natin si B by covering this one. Okay. And then, replacing s with the value of the pole of this. Okay. So, we will have 10 over s times s plus 3 square when s is negative 2. Yung s equals negative 2, ito yung pole nito. Okay. So, basically, this is 1 square negative 2. So, this is negative 5. Tama ba? Okay. So, it's letter, that's your D. Okay. Yung C naman, mamaya natin ito masasolve kasi hindi natin siya basa natatakpan kasi dalawa siya. Yung D ang unahin natin. So, yung D basically, again, tatakpan ko ito. This is 10 over s times s plus 2 when s is negative 3. Yung s negative 3 is yung pole nito. Okay. So, this is basically negative 3 times negative 1. Okay. So, that's negative times negative 1. So, that's positive 3. So, this is 10 over 3. Okay. So, yan. So, you have now tatlo. 5 over 9, negative 5. Okay. Plus 10 over 3. Okay, so yung C na lang. Yung C. Okay. Makukuha nyo to by so yung C makukuha by taking the derivative, okay, of again, ito yung factor niya, tatakpan natin siya dito. Okay, tatakpan natin siya dito. So magiging, so ang kukuha natin derivative is 10 over s times s plus 2. Okay, when s is negative 3. Okay, so parang it's the way by which we obtain d, pero i-derivative natin siya. Okay, kukuha natin yung derivative niya. Okay, so pagka ganito yung problem niya, pwede nyo itong i-direct sa calculator. Okay, so huwag tayo ng calculator dito. Ayan, so we will have yung derivative ng 10 over alpha x times alpha x plus 2. Okay, when x is negative 3. Okay, so basically negative 3 na. Negative 3. So this should give us 4.4444. Okay, so ganito yan. Since repeated ito, pwede itong i-express as a rational, number. Okay, now, without showing yung kung paano siya gagawin i-convert sa isang rational number. Pero basically, yung 4.444 na yan, that's 40 divided by 9. Ayan. 40 over 9 equal yan sa 4.4444 na repeated. Okay. So basically, ayan. Pwede rin ito, i-treat ngayon, or i-suit ito as 40 over 9. Okay. So, ayan. Meron tayo ngayong coefficients na 5 over 9, negative 5, 10 over 3, at saka 40 over 9. Okay. So, ayan. Now, sulat natin ngayon yung fraction natin. So, ito na siya. Okay. So, we will have now f of s equals, yung a natin is basically, yung a natin is 5 over 9. So, this is 5 over 9 over s. Okay. So, yung b natin is negative 5. So, minus 5 over s plus 2. Tapos, yung c natin is 40 over 9. Okay. So, yung c natin is 40 over 9. So, this is plus 40 over 9 over s plus 3 plus ito 10 over 3 divided by s plus 3 squared. Okay, so yan na yung expansion ng natin. Ngayon, since nakaganyan na siya, pwede natin itong kunin ng inverse Laplace transform. Pero mag-refer tayo sa table natin. Okay, so mag-refer tayo sa table natin. So, trace muna natin ito para mas makita natin. Ayan. Okay. So, una, yung itong term na ito. Okay. So, ang pinakakatapat niyan ay ito. Yung 1 over s na yan. So, basically, ilalabas natin yung constant na 5 over 9, tapos meron tayong 1 over s dito. So, i-inverse natin yung 1 over s na yan, which is u of t nga. Pero, dito, in this case, yung u of t, papalitan na natin ng 1. Okay? So, basically, yung unang term natin is basically 5 over 9 times 1. Kasi yung inverse ng 1 over s is 1 lang. Is 1 na lang. Okay. So we have the first term as 5 over 9. Okay. Next. You have s plus 2. Okay. So anong entry dito? Yung pinakamalapit na form yung sa table. So makikita natin, ito yan. Okay. So 1 over s plus a. So in that case, yung a natin ay 2. Okay. So lalabas ngayon dyan, ito siya. E raised to since ang a mo dito ay positive 2, okay, plus 2 ito. So, lalabas yan, e raised to negative 2 times t. Ito. Okay, again, ito natin is 1. Okay, pero may 5 dito. So, ilalabas natin sa 5. Okay, so this is 5. Tapos, yung inverse ng 1 over s plus 2 is e raised to negative 2t. Okay. Then, plus, similar siya dito, you would have 40 over 9 e raised to negative 3t. Okay? So, ayan. Now, paano ngayon to? Paano ngayon to? Ang pinakamalapit na form dyan basically is ito. Okay, ito. Which turns you to this. Kaya lang, kung papasin nyo, yung s na to, hindi, instead na s siya, s plus 3. Okay. So, kapag ganun, basically, ang lumalabas dito is that in-applyan to ng frequency shifting. Okay. So, kung in-applyan to ng frequency shifting, it means na pwede kong iterate muna ito as 10, pwede ko muna iterate yung inverse nito originally as 10 over 3 over s square. Okay, in which ibibigay niya sa akin yung inverse na t, 10 over 3 times t. Pero since dahil nga s plus 3 ito, nakamultiply yung inverse ko ng exponential na e raised to negative 3t. Okay, so lalabas ngayon dyan, you would have plus 10 over 3 t dahil dun sa s square. Okay, pero dahil s plus 3 ito, you will have e raised to negative 3t para makuha mo yung complete na inverse niya. Okay, so yun yung makikita natin inverse nito. Okay. Okay. Number 3. So, we want to solve the differential equation na ito. Okay. Using the Laplace transform when all the initial conditions are 0. Okay. So, in this example, dito makikita na kung gaano kabilis gamitin yung Laplace transform sa pag-solve ng mga differential equations na merong constant coefficients. Okay. So, solve natin yung given. We will have d square y over dt square plus 12 dy over dt plus 32y equals 32. Okay. So, ang gagawin natin dito, basically, is ano mo natin yung kunin natin yung Laplace transform niya. Okay. Pero, tandaan natin na halimbawa itong una. Pag kinuha ko yung Laplace transform ito, so yung Laplace transform ng d square y over dt square, kung matatandaan nyo ito sa property, you would have s square y of s, okay, minus sy of 0 negative minus y prime of 0 negative. Okay. Kaya nga lang, ang sabi natin, 0 initial conditions. So, lalabas ito at saka to, 0 to. Okay. So, ang magiging Laplace transform lang nito, basically, is ito. Okay. So, ganun din dito. Yung initial condition nito na dapat nag-result natin, gagawin natin 0. Okay. So, ito lalabas ngayon siya. We would have s square y of s plus 12 y of s. Okay. Sorry, 12s y of s plus 32 y of s equals 32 over s. Okay. So, s square y of s plus 12s y of s plus 32 y of s equals 32 over s. Okay. Now, ngayon, pwede natin i-factor itong y of s na to. Okay. Tandaan nyo, kung i-solve natin to, ang kailangan sagot nyo dito is y of t. Para ma-solve nyo to. Okay. Para ma-solve nyo itong differential equation to, ang kailangan nyo hanapin is yung expression para sa y of t. Yun yung solution niya. Okay. So, ngayon, i-factor out natin yung y of s dito. Since common naman siya sa lahat, you would have s squared plus 12s plus 32 times y of s equals 32 over s. And then solving for y of s, you would have y of s equals 32 over s times s squared plus 12s plus 32. Yan. Okay. Again, ang kailangan nyo i-solve y of t. So, ano ko natin ito, y of s. So, ano bang relationship between y of t at saka y of s? Okay. So, alam natin na si y of t ay inverse ni y of s. So, kaya ang gagawin natin, kukunin natin yung inverse nito. Okay. So, ayan. Ngayon, kung kukuha tayo ng inverse nito, since naka-rational function ito, again, ang titingnan nyo is, kung itong denominator ninyo, pwede nyo bang gawin linear factors. Kung meron bang linear factors lahat ng denominator to. So, okay na kayo sa s. Ito na lang. May linear factor ba tong s squared plus 12s plus 32? Or may ipa-factor nyo ba tong s squared plus 12s plus 32 sa linear factors? Okay? So, mukhang meron naman. Okay. So, yung ibibigay nyo sa inyong linear factor is 32 over s times s squared plus 12s plus 32. Bibigyan niya kayo ng linear factors na s times, mukhang s plus 4 at saka s plus 8. Okay? Kasi yung sum niya, yung product niya is 32, yung sum niya 12. So, naka-linear factors ito. So, medyo madali rin ito kung tutusin. Okay? So, ang partial fraction expansion nito is basically a over s plus b over s plus 4 plus c over s plus 8. Okay? So, solve natin isa-isa ngayon. So, a natin is basically, again, by cover-up method, this is 32 over s plus 4 times s plus 8. Okay? When s equals 0. So, yung pole kasi nito ay 0. So, yung isa-substitute natin para ma-solve siya. Okay? So, this is 32 divided by 32. So, this is 1. Okay? Then, yung letter b natin is 32 over s times s plus 8 when s is negative 4. So, yung negative 4, okay, yung negative 4 dito is basically the pole of this one, of this term. Okay, so you would have negative 4 times 4. So, 32 over negative 16, that should give you negative 2. Okay. Then, letter C. Solving for letter C, you would have 32. Okay. Ayan. Over s times s plus 4 when s is negative 8. So, this becomes negative 4. So, negative 8 times negative 4, that should be positive 32 divided by 32. That should give you 1. Positive 1. Okay. So, yung mga ano natin is 1, negative 2, tsaka 1. So, yan. 1, negative 2, tsaka 1. Okay. So, writing now, itong y of s natin, we will have, ang a natin is 1. So, this is 1 over s. Okay. Kasi yung b natin is negative 2. Okay. Yung b natin pa dito is negative 2. So, you will have minus 2 over s plus 4. Tapos, yung c natin is 1. So, you will have plus 1 over s plus 8. Okay. So, yung inverse ito ngayon is simply 1 over s is simply 1. Okay, galing sa table. Okay, ito naman, 2e raised to negative 40. Okay, and then yung huli, the last term, which is 1 times e raised to negative 80. So this would be your solution. It is solution ng differential equation mo. Okay?